we have a florist. We have bouquets 1, 2, and 3. Each of the bouquets is to be composed of one or more of 5 kinds of flowers. And then we have LPSRT. They said each bouquet is to be composed of one or more. So I have my 3 bouquets. I'm going to go ahead and put my at least 1 dash under each one. Right? 1, 2, 3. Because every one has to have at least 1. They did say that we have this option. We have these 5 kinds of flowers. 1 or more of 5 kinds of flowers. When it comes to the flowers, how often does each of these kinds have to appear?
Doesn't say. We don't know. Well, at least once.
That's the question. Is it 0 or 1?
0.
Is it at least 1 or at least 0? How many people say 0? How many people say at least 1? Okay? It's at least 0. I mean, that's not even a phrase, but it's 0. And the reason for that is that it just says that each one of the bouquets has to have 1 or more of 5 kinds. So in theory, without looking at any of the rules, you could have all of them be lilies. Right? So, lily, 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 lily. Well, actually, you don't have 1. Right now, that's all it could be the case. So anyways, that makes this game a little challenging. 1 and 3. Bouquets 1 and 3 cannot have any kind of flower in common. Okay, so I'm going to go ahead and just... This goes back to what we just talked about. Were you asking about that? Yeah, we could switch the order, but it seems a little weird too. So maybe that's why I don't. But anyways, 2 and 3 must have exactly 2 kinds of flowers in common. Something to keep in mind. So that means each of these flowers, or each of these bouquets, has to have at least 2, and they have to be equal to each other. There's a couple ways to do that. Because they're right next to each other, I'm just going to keep it simple and do an equal sign. Sometimes in a game, you might, there might be an ordering game like this, and they're like 6, and they might say slots 1 and 4 have to be the same. Well, they're far enough away, you may do something like this, and then if they're like slots 3 and 6 have to be the same, you might do a different symbol. And that's one way of showing, hey, these guys are going to be the same and these guys are going to be the same. So whatever you put here, you got to put there. Whatever you put there, you got to put there, and vice versa. Right? So we could do that over here. I could do square, 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 or something like, well, actually, probably wouldn't want to do 4 squares because I would suggest they all have to be the same, but maybe square, square, and circle, circle, or something like that, right? Or triangle. It doesn't matter. There are multiple ways to symbolize things, but those are some ideas. Okay, anyways. One thing that they say here is they use the word exactly. So must have exactly 2 kinds of flowers in common. That means that, let's just say I had SR, SR, right? If I have P here, what cannot happen? I can't have P and 3 because then you'd have exactly 3 kinds, right? If they had said bouquets 2 and 3 must have at least 2 kinds of flowers in common, then I'd have 2, 2, and then I could have more. I don't care, right? But now I gotta limit it to 2. So if I have SR, SR, and I have P here, I can't have P there. Or if I have P here, I can't have P there. Because then I'd have exactly 3 in common. Anyway, just something to keep in mind. The word exactly in the games is pretty restrictive. Bouquet 3 must have snapdragons. Now, at first, it was like, okay, wait, hold up. I don't know if Snapdragons is going to be the one that repeats. So I actually decided to write it up here. Or you could put it down there. I just didn't want to commit to that yet, right? I know it's there, I just don't know if it's going to be a repeater. If a bouquet has lilies, that bouquet must also have roses but cannot have snapdragons. So if you have L, then you have roses, but you don't have snapdragons. I'm going to draw, you can draw this rule, if-then rule, left to right like we usually do with if-then statements, but it's a grouping rule, right? It has to do with what's going to happen in the group, so I decided to write it vertically. Any inferences we can make from that?
Well, B1 can't have snapdragons? They can't have any.
Well, okay, so this actually comes from that rule right there.
Yeah.
Right? Like if you're like S is here and S and 3 and 1 can't be the same, then I'm never gonna have snapdragons here. Yeah.
I have a question. I tried to do like the contrapositive, and I just don't think I got it right. Like, what is the contrapositive?
Well, the contrapositive is if you don't have R's or you do have S's, then you don't have L's.
Okay.
I don't usually write the contrapositive, and I think that you'll probably be okay if you don't. I mean, so here's the thing. Like, imagine. Well, let's talk about this for a second. Can you put L in 3?
No.
Are you cool with that? Are you cool seeing that from this?
Yeah.
Like, if S is in 3 and I try to put L over here, then I can't have S. So I'm like, oh wait, I better not do it. So I just usually just keep the original rule. All right, so that's the inference. Are we cool with this so far? Okay. So we know we have S here, which means we can't have S here, and we know we can't have L. You know what? This is not. Actually, on my page, I wrote the not L up there, but I don't have a lot of space up there. So I'm going to do this down here. I got S in here, but I don't have L, and then I know I don't have S down here. And the reason I'm doing these all together, oh shoot, I hope you guys can see this. So I got my S and my not S down here. The reason I'm doing the S and the not L together is that I want to. The games is often about what is not in front of you. So, how many variables are there in this game? There are 5, right? And a lot of times the answer is going to come from who's ever left. Remember the last game we were doing, and we kept being like, who's left? And it was like I, H, and M. Like that's where the final inferences take place, and where a lot of people stop. It's out of sight, out of mind, and so they're like, oh, I don't know what happens next. Let's go answer the question. But the reality is, if you can keep thinking about, well, who hasn't been addressed yet, you might realize that there's still inferences to be made. Still things that you can figure out from the information you have, right? So by listing these folks together, it becomes easier to realize, one, how many variables are left, and once you know how many are left, it's pretty easy to figure out who they are. Like if you know there's only one left, it's very easy, right? It almost invites you, like it'd be stupid not to figure out who that is. Here, we have 2 variables already addressed, so that means there are 3 left, right? Who are they? Can you say them without looking up at the list? PT, right? And R, PTR. So, like, I don't know, like, you might be like, oh, wait, I know something about P, and I know something about T. So, anyways, just try to keep stuff together so you can figure out how many are left. If a bouquet has tulips, that bouquet must also have... What is that flower?
Peonies.
Never heard of that.
Really?
No. Stick with lilies, roses. What is this?
Bigger roses.
Is it? Are we dealing with? We are dealing with roses. Snapdragons, whatever. This stuff is weird. So, okay, it's T, then P. Okay. One thing about these if-then statements is, right? This is very different from saying this. What's the difference between those two things?
T has to be with P, and then the other one is if T, then there is a P with T. But P doesn't have to be with
Wait,
P.
you sound like you said the same thing.
Sorry. So the first one, T has to be with P, so and P has to be with T. So they're always going to be together.
They're always together.
Yeah.
So this is actually like writing, not that we'd ever do that, but that's the same thing. You're saying if I have T, I have P, if I have P, I have T, right? Like this is a stronger rule than this one. This one is not saying as much. This one is only saying what?
If there's a T, then P is there, but if P is there, it doesn't necessarily mean there's going to be a P.
That's exactly right. So now, what that means is that in this scenario, they're together. We talked about that in the last game. In this scenario, they're not necessarily always together. Ironically, who's going to show up more? P. Because if you have T, you have to have P, but you could just have P by itself. So that seems to be something that's very common in these games. Like when you have these if-then statements and it's a grouping game, you're going to find a lot of groups that have to have P or have to have R. Because you're maybe down to two variables, you're down to L and R, and you're like, well, if I have R, if R ends up coming into this group, then I have R. If L comes into this group, then I have R. So either way, I'm going to get R, right? So there are a lot of groups that just end up having R or P, no matter what, even if you don't end up with T or L. Just something to keep in mind. Okay. That's all the rules. Did anyone create worlds for this game? On the basis of?
Okay, 3.
Oh, interesting. What was your thought process?
So it always has to have S, and then it can only be T and P, P and R, or T and R.
Okay, interesting. Now, so you said you created 3 worlds.
Sorry, I messed that up.
Okay.
T for Bouquet 3 can be T, P, and S, S and R, P and S, or P, R, S. And then that informs what can be, or what at least has to be in Bouquet 2.
Okay. Is there ever a situation where you only have 2 in Bouquet 3?
Yes.
Which one?
S and R or P and S.
P and S, S and R. Okay. Okay. Yeah, otherwise, you're going to have more. Okay, interesting. So you said I either have S with P, S with R, or TPS, yeah,
Or PRS.
or PRS. Yeah, that's kind of cool. Anyone else do worlds on the basis of that? Okay. So my initial gut reaction, just kind of like going based on, that's a great idea. Going off of trends, I was like, wait, L can't go here. So then L has to go here, here. I could create 2 worlds on the basis of L, but there's also this other option, right, that L never shows up anywhere. So then I was like, oh, well, so there's no L, there's L here, L there, there's L in both. And then I was like, forget it. So I didn't do worlds. But anyone else doing worlds on the basis of anything else? Okay, that's an interesting challenge. I would say that's homework, actually. Is do world, you have a vague sense. You're like, I heard some letters about group 3. I didn't do it that way, so whatever. But keep in mind, you could do worlds on the basis of group 3. You just have to figure out what all the options are. And if you can figure that out, it's a good mental challenge, and then see how the game plays out. If you don't, let's go ahead and go through it without worlds, so you can see how it works just going to the if questions, right? Question number 19 is our traditional first question. So I'm going to go ahead and just grab rules and eliminate. What's the easiest rule to grab?
S has to go in 3.
Yeah, S has to go in 3, right? So that's going to get rid of E. All right, what's another easy rule?
2. Bouquet 2 and 3 have to have 2 of the same.
Okay, Bouquet 2 and 3 have to have exactly 2 of the same. That's actually a little bit harder of a rule to apply, but it's definitely doable. Looks like D is fine, C is fine, B is fine, A, PRT, PST. Oh, that's all fine. Okay, what's another rule? Yeah.
No lilies and snapdragons together.
Oh, okay, L and S can't be together. Sure. So you say, okay, L and S, are they ever together? Ooh, that's a problem in D. So D is out. How about L and R have to be, well, not that they have to be together, but if you have L, you have to have R, right? So if you have L, then you have to have R. Is that ever a problem in A, B, and C? No. If I have L, I have R, so we're good. How about TP? If you have T, then you have to have P. Is that a problem? C has T in Bouquet 2, but it does not have P, so C is out. 1 and 3, they can't be the same, right? So I'm going back to A and B. Do they have anything in common? B has P in common, right? That's not good, so the answer is A. Alright, question 20. If lilies are in Bouquet 1, which reply must be true? Okay, So for question 20, I'm going to say 1, 2, 3, 1, 2. And if L is in 1, what do you know? R is in 1 as well, right? So I'm going to go ahead and put that in there. If L and R are in 1, what do you know about 1?
That's it.
Okay? 1 connects to 3. You guys cool with that? Like you just look back over there, like, okay, 1 can't be with 3. So over here I'm going to write not L and not R. Sound good? Who's left at this point? S, P, and T, right? So you got those 3. And so what do you know must be true? S, right? S has got to be in here. I'm just going to go ahead and write that in even if I don't know whether it's a repeater, just to get it on there. And then I have P and T left. And what do you know between those two?
P has to be.
P has to be. That's the thing that they're going to test over and over again. Because if you have P, you have P. And if you have T, you have to have P. You guys cool with that? Questions? So I'm going to go ahead and put P here. Okay, so I still don't know about T. T is a question mark, right? It certainly could be there. But because I have these two, do they have to be the ones that repeat?
You could have T, and that could be a repeat.
You could have T and that could be a repeater, yep?
I was gonna say, could you have no P, but I guess.
You can't. Really, because there's only 3 variables left, right? There's SPT, you know you have S, so you're down to PT, and if you have T, you have P, if you have P, you have P. So either way, you're going to have P. Now, what I do know, though, is that if I have S and P here and I can only have one more, well, at least one of these has to repeat. Right? So I'm just going to go ahead and write that in. So that's all that must be true. Yeah?
I get why P doesn't have to be with T, but can you explain again why P has to be
In the third group?
third?
Yeah. So are you cool that L and R are gone?
Mm-hmm.
And you're cool that S is there. So who's left?
P and T.
Okay, so P and T are the only things that are left. Now, how many of those 2 variables that are left, P and T, how many of them do we need? Do we need to put any of them in group 3?
Yes.
Why?
We need to have at least one because there have to be exactly two that are the same between.
That's right. So that group, you know, has at least 2, right? We know we have S, L and R are gone. So the only things that are left are P and T, and I got to put at least one of them. I could put both because there's no like cap on the group, right? But I have to put at least one of them in the group. So I'm trying to decide: do I put P in or do I put T in? But the thing is, if I put P in, it's over. T could come in. It doesn't. T could do whatever it wants. If I put T in, what's going to happen?
Then P is also there.
It has to come in. Like T depends on P. T is gonna drag P along because P is its baggage. So, I guess there's only 2 options, P or T. And if I have P, then I have P. And if I have T, then I have P as well. So no matter what, I'm gonna end up with P. So then I just put it in. I'm not saying that T isn't here. I'm just saying. Is that cool? Okay.
Yes, thank you.
All right, so which one probably must be true? L is in 2, no, not necessarily. P is in 3, yes. That's the answer. Okay, questions on that one? Okay, let's go to 21. If tulips are in bouquet 1, which one of the following could be a complete and accurate list of the kinds of flowers in bouquet 2? Okay, so 21, 1, 2, 3, 1, 2. I'm not numbering these because I don't feel like we need to number 1, 2, and 3. If T is in 1, oh, this sounds like it's going to be the same kind of test. What happens?
P is in
P's got to be in 1. And what do you know if P and T are in 1?
S and R.
Okay, yeah, that's correct. So really quick, we say T is not here, we know P is not here, we know L is not here, always, right? That's a huge victory. If you can cross out 3 things and there's only 5 things in this game, you know that there are 2 left, they have to be in 3. Right, so S and R go here, and they're the only things in 3. So since I know that they're the only things in 3, what else do I know? They have to be in 2, right? So we have S and R. Now, this group is done, I guess we No, we can't have more in this group. Why can't we have more in this group?
Because you can't have anything that overlaps with 3.
Can't have anything that would coordinate with 3, right? So you can't have S and R. Why not L though?
So you have to have R.
You'd have to have R, right? So this group is done. This group is done. This one, it still seems like I could have L. It still seems like I could have P and T. I don't see why I couldn't have any of these variables here.
You couldn't have L because you have R. I mean, you have S.
Ah, yes, L. Okay, so L would not work here. But P and T, I don't see a problem with that. You guys cool with this? Yes, question.
I'm sorry, can you explain again
Why L can't be in the third one. So that's an inference that we made at the beginning.
Oh, okay, sorry.
And no, it's alright though. The reason for it is that S is here, and if S is here, you can't put L because L, yeah. Okay. So, which one of the following could be a complete and accurate list of the kinds of flowers in bouquet 2? Well, even if you don't make this inference right here, or even these inferences, you're just like, I know SR has to be there. The correct answer has to have SR, and then you can just see what's left. So A is out, B is out, C is out, D is out, E is the only one that has SR, and then it's like, okay, well, could I get P and T in there? If you weren't sure at the time, you just think about it, you're like, well, it's the only option that will work. But yeah, there's no problem with this because there's no rules about 2 in relationship to 1 and 3, except for they have to share 2 in common. So the answer is E. All right, 22 is not an if question. So since I didn't do worlds and they're not complete, and I just have these diagrams, I'm going to skip it. I'm going to do all my if questions first. Then let's see here, 23. Oh, that's also a non-if question. So I'm going to go back to 22. Which one of the following cannot be a complete and accurate list of the kinds of flowers in 2? Okay. Well, the reason I do my non-if questions later is because now I have these valid diagrams, right? So let's take a look at A. Could L and R be in 2? Maybe. Like I could do LRP, maybe?
But it's a complete list.
Oh, that's true. That's not good, is it? Okay. Well, it's never gonna work. If you have LR and that's your complete list, what does that actually mean? What's gonna happen? It's gonna go into 3, and that's not gonna work out. Okay. Well, actually, that's the question. Okay. Well, if you didn't see that, PT, I'm thinking, why not? It could go here. PRS, again, why not? It could go here. PRT, PRT maybe could go here if T was overlapping. PRST, I think that's what we actually talked about here. So I'd be like, yeah, those all work. So if you can cross out 4 answers, you're also good. Okay, let's go to 23. Which of the following cannot be true? Okay, L and R are the only kinds of flowers in bouquet 1. Could that be true? That could be true. It's in question 20, right? Okay. B, P and T are the only kind of flowers in bouquet 1. Yeah, that happened here, so that could be true. So A and B are out. C, L, P, and R are the only kinds of flowers in bouquet 2. LPR, we don't have, that's not going to work there. This doesn't work there. We don't have that. So I would actually just keep going. I would like leave that open. Be like, I don't know. It seems like it could work. D, PRS are the only kinds of flowers in bouquet 2. How about PRS? Yeah, that could definitely work here. So that's out. E, PST are the only kinds of flowers in 3. PST. If we had SP and then T, I don't see why that's a problem. So that's out. So you could do one of 2 things. You could go back and be like, C is the only answer open, pick it. Or you can try to show why that can't be true. PRS, if they're the only ones, PRS, if these are the only ones here, what happens?
It's LPR.
I can't read it. LPR. Oh, jeez. Okay, LPR. Okay, what happens? Anything? What do we know must be true? Okay, if these are the only 3 and 2, right? L can't come over here because we figured out it can't go with S. So P and R have to be the ones that come over, right? So these are the ones that are like matching. You guys cool with that? Okay, what else do we know at this point in the game? S has got to be over here, right? Because it's just always over here. Okay, so far so good. Okay, if PRS are over here, what do you know? Can't be in one. So you can't have P, you can't have R, can't have S. So who you got to put over here? T or L. The problem with T and L is that they both have baggage, right? If you bring T over, then you're going to have P, not good. If you bring L over, then you're going to have R, not good. So this doesn't work out. That's why C can't be true. I think it's a lot easier though the C, the A, B, D, and E can be true just by looking at your other diagrams. But if you can see this, great. All right, questions on this game? Takeaways? Uh-oh, no takeaways?
It's a little confusing to me, like why you use those 2 diagrams to like base the rest of the questions off of.
Oh, like why can't I?
Yeah.
Well, so questions 22 and 23 they're called universal questions sometimes because they're just like, which one of the following cannot be true for the group 2 or whatever, right? And so if you can ever see a situation in which it worked,
Yeah.
even though there were additional constraints in that question, because there were additional constraints for both of these questions, we're like, well, that doesn't always have to be false. Because cannot be true means never possible. So I'm like, well, it was possible once here, so that's wrong. What was question 23? Question 23, oh, that was also cannot be true. But it wouldn't matter, even if it was like a must be true question, you'd just be like, does this always have to be true? No, here's a situation in which this didn't happen, so that doesn't have to be true, that's wrong. Could be true questions are even easier. If they just say, which one could be true? Again, it's a universal question, they're just asking, could this ever happen? And you're like, oh yeah, I saw it happen here. So if it can happen here under a more narrow set of circumstances, then it can definitely happen at least once, done. Does that answer your question? Cool. Yes?
So, as you're approaching the games, like, when you see you explain it, it makes sense to me why, like, T, P, and L, for example, can't go there. But
Yeah.
I have a hard time making those kinds of inferences when I'm trying to quickly go through a game. Like,
Yeah.
what kind of questions are you asking yourself as you're going through the game to, like, not take up too much time, but to make inferences that then don't end up turning out to be too constraining?
Yes. Yeah, that's actually kind of the golden question is, what happens in the games, by the way, and in the tests in general, we'll talk about this more in a little bit, but they basically give you facts, right? They give you 3 facts, for example, and then they're asking you to figure out what must be true on the basis of those facts. And the biggest mistakes that people make in the games is either they make one inference, but they really could have made 2, right? So they don't go far enough. Or they can only make 2 inferences, but they end up making 3 or 4. And sometimes we do this consciously. Have you guys ever found yourself in the games being like, okay, if T is second, then S is probably third. Like, I mean, it seems like it should go there, and so then you just put it in there. Well, if it's true that S can only go in third, and it has to go in third, then writing S in third is totally fine. But if S could go in 3 and 4, and you just wrote it in 3, well, now you've just constrained the game in a way that doesn't have to be constrained. And making this mistake, going too far, is worse than not going far enough. Because when you don't go far enough, you still have possibilities open to you, so you may not eliminate answers that could actually be correct. But when you go too far, you often get rid of answers that are correct. So anyways, how do you find the happy medium, right? Well, it usually comes down to two questions. Who's left? And what do I know about who's left? And it's just like you're on repeat for that over and over and over again. And you may not realize that you're doing it, but that's essentially what you're doing. When they tell you, oh, like for example, for this question, right? When they told us that T was in first, the question is, well, I guess I'm actually starting with this question because they told me that T is here. My question is, what do I know about T, right? And then the answer to that question is, I know that P has to be with T. So I write that down, and then I'm still actually asking this question. What do I know about T? What do I know about slot 1? What do you know about slot 1? It can't be the same as slot 3. So that leads me to write down this stuff, right? And that's where a lot of people stop. They're asking themselves this question, but they're forgetting to ask themselves this question. Because when you ask yourself who's left, it doesn't even matter if you don't have a complete list. Who's left at this point? S, L, and R, right? And you may only remember S. But that alone could be immensely helpful. You're like, oh, let's see, who's left? S is left. What do I know about S? Oh, S has to be here. Oh, okay, well, S is in this list. And now you have 3 of your 5. And then if you ask yourself again, who else is left? Because you know there's more, but you don't remember. Then you're like, L. Oh, yeah, L. And it can't be here, right? Like, sometimes you don't remember that until you ask yourself who's left. And then just becoming aware of the variable is enough to remind you of what you know about it. And then you write it down. Now, where are the answers to these two questions? Well, who's left? You often just have to look back here. And what do you know about them? If you've drawn your diagram well, like you've kept everything close but clean, you're just circling around like this. So I'm constantly circling around here, and the answers to these two questions are right there. And that's why we also write the floaters. Because the floaters answer this question for you faster than if you didn't have it. Right? Because if you ask yourself who's left and you look at this diagram, there aren't any floaters in this game, I don't think, yeah. But the rules themselves are prompting you to remember who's left. Because you're like, oh, I guess I know something about T, I know something about L, and all of a sudden you remember the variables. But that's kind of the secret sauce, really. If you just do this over and over again, you'll keep going until you run out of inferences. And then you're just listing out the variables, and you're like, I don't know anything about these remaining variables. That means you're done. So you also know that you're done answering or making inferences because this question is nothing. You say, I don't know anything about the ones that are left. That was kind of a long answer, but...
That's really helpful.
Cool. Any other questions? Yes?
For this game, could it be a good strategy to do worlds based on whether S is one of the ones that is like matching in 2 and 3?
Yeah, I mean, there's only 2 options, right? Either S is going to be matching, or it's not. So that answers the first question, 2 worlds, right? And
Right.
that's not too many. That's great. But then the next question is, do you remember the next question?
Does it determine a lot of variables?
Yeah, is it helpful, right? And yeah, I mean, it seems like it could be helpful. Like if S is not one of the 2, then you know you got to get 2 of the others. It's not going to be L, so it's got to be PT or R.
Mm-hmm.
And then
I think it has to be P or T.
maybe it has to be P or T. I don't know. Well,
It could be
Yeah.
P and R.
it could be P and R. Could it be R and T? No, because you'd have to have P. But it could, yeah. I don't know. So you could just try it out. You just create them. That's the thing is, there is not a whole lot of harm if you're moving fast. You just say, okay, well, here are 2 options. It may not turn out to be helpful, but you may not know that until you start it. You start it, and then you're like, oh, actually, I see now that this has to be true. And then you have a semi-complete world here and maybe an empty world here, but those are your only 2 options. And as you're going through the questions, you're like, which one am I in? And that can just jump you forward into the inferences. Because with that last game, right, we kept looking and we're like, well, not these 2, so we're over here. So we know FL has to be here, and that may be enough to answer the question. So, yeah, but there's that other option of just saying, hey, what are my only possibilities for 3? And that's an interesting challenge as well. Okay, good questions. Anything else? Okay.